out of twin lead and a piece of coax, throw them up in a tree, and have them at locations around where their gathering is. So replacement antennas are another option. These are all things that are fun to try to do. To go back also to what Bernie was talking about using FRS, GMRS, various types of radios. My wife and I got into recreational kayaking a couple years ago, and I'd go on these trips, and some people on the trip would have FRS, some would have GMRS, some would have marine radio. Well, the older Yaesu RD50, the earlier serial numbers, you can modify to do all of those. So I have one radio that does them all. You're not supposed to do that with marine radio.
But that doesn't stop people from doing it.
No.
I just want to mention that radio Skip has is probably one of the most hackable two-way radios ever designed by Yaesu. It was very popular in the hacker community. You can still find them on eBay. It's the RD50. Is it
RD50.
Okay, I have one.
FT50RD.
The FT, right? FT50, Fox Tango 50, and there's also called the Fox Tango 50R.
If you do find one, though, be careful. The later serial number ones aren't as hackable. There's a lot of information about that on the web if you actually do run across one. Though.
They can also receive a very wide range of frequencies. And back when analog cellular was still active, up until a few months ago, you could listen to cellular phone calls on these things. There's a voice recorder. There's an audio recorder built into it. It's really amazing little radio. They don't make them anymore, unfortunately.
Not that listening to cell phones is legal.
That would be wrong.
Just so you know, that would be wrong. Nobody up here has ever done that.
Today,
the other part I wanted to talk about in practical communication, again, going back to the idea of an activist gathering, is make sure you understand the limits of your equipment in terms of power. Power transmission, power consumption. There's nothing worse than gathering a bunch of people together for an important demonstration or important activity, and just when things start to get a little interesting, have the batteries crap out on your radio. Not a good thing. So first thing, know the practical power consumption of your radio. Go back to what we were saying earlier. You know, it's not 5 watts, it's 1.58. Do what you can to improve that. But then on the other hand, know the power consumption factor of your batteries, whether it's nickel metal hydride, nickel cadmium, alkaline, whatever you're using. Find a radio where you can do quick and dirty battery replacements. If you're using rechargeable stuff, keep it recharged. A lot of units will sell a battery pack that lets you use a field expedient of just adding regular alkaline batteries. So if your rechargeable circuits have failed you for the day, you find the local convenience store and you just pick up some batteries and you can keep your...
and unfortunately, most models tend to limit the output power when you're using alkaline cells because you can't draw as much current from them.
Right.
But
at least
it's
it
a
gets
good,
you back on
it's
the
a good
air.
option.
And just so you know, the Tri-Square, the 900 megahertz spread spectrum radio comes with rechargeable batteries, but then you can pull that pack out and put AA's in it.
And I forgot to mention on these radios you can get 2 for $80 on Amazon. Also, they also do text messaging. You can do fairly secure text messaging between radios, maybe a mile or so away. You can store canned messages, and they're really worth checking out.
The only drawback to the text messaging that I found out when my wife and I used them was that it does not tell you that it got delivered. It's just transmitting it in the blind, unconnected. So if the message doesn't go through, the message didn't go through. And you have no way to know that you get no acknowledgement back that it came through, which I think is which is an area of improvement for them. But okay.
The one other thing is if you think about it, most radios have some ability to plug in a wall wart circuit or a car, what we used to call a cigarette lighter, now we call a utility plug or something, whatever it is. Find whatever radios you're using, find a way to get from 13.8 volts, 12 to 14 volts to the voltage your radio needs some way, because there's always a car around. You can always pop the hood and just hook up.
Most amateur radio equipment accepts 12-volt supplies.
Right.
It's incredibly common. So
And even other equipment that doesn't use, like, uses batteries, there's little voltage converters you can get that'll convert 12 volts down to 4.5 volts or 6 volts or whatever the radio happens to use.
This, I'm going to go over to the screen again. I've modified this cable, oops, sorry, in addition to just being to the utility plug. Common radio connectors for power are something called power poles.
Drop it down low.
And the earlier tradition before power poles were invented was something called Molex. So I built this cable so I have the common standards all in line. So if I run across another group of people who are doing radio and I have the ability to draw power from them, I can just pop out that cable. But like I said, in the long run, in a real emergency, just being able to tap a car battery is a great way to go. And it's all about just, keeping your communication lines open and working throughout the extent of your gathering.
What about solar power, Skip?
That's right.
This is my absolute favorite. Now, Ed showed this to me like a year ago or something. It's
I want to do see, I think that you could do this. Go ahead.
Oh, as Skip was saying, being able to, the whole point of this panel was off the grid radio communications. And that means not only are you off the grid of a communications infrastructure that relies on corporate government networks. This is completely wireless and using no other infrastructure. There's the power infrastructure too that we all are reliant on. But you can use batteries and rechargeable batteries and photovoltaic panels or solar panels like this. This happens to be a military surplus unit, which is really nice. It folds up like a notebook. It generates about 15 watts of power. That would easily charge batteries for any of these devices we've just shown here today. So if you really want to be off the grid, I mean, you can be free of any infrastructure between you and the party you're communicating with, and free of any infrastructure as far as the power grid goes. So off the grid communications is really possible.
Now, the actual output power of the radio is significantly less than the input power that you supply to it. So, for instance, if this is a 15-watt panel, you may only get a couple of watts out of the radio. But when you're using shortwave bands or line-of-sight VHF, UHF communications, that's almost enough. You almost don't even need a battery in a lot of cases. So if you only have solar panel, last-ditch kind of need to get the message out, it works.
I think we're good.
Okay.
You want to ask questions?
Is that me?
Yeah.
All right. So we talked about some stuff where you're completely off the grid. Okay. You're not relying on anybody else to do anything. Now, of course, you could build your own grid, sort of, right? Okay. So you're going to connect, and you want to have long distance communications between two different locations. Let's just say. So, or you want to have you want to put your own repeater up. In the ham band, maybe not in the ham band, okay? So D-Star is a new mode, is a modulation technique that was developed by the Japanese amateur radio, or actually Relay League. And they own the standard, although one of the problems with it is that only one manufacturer is making the radios right now. So the price is maintaining itself, not really at a good level. To put a whole stack of all three bands with a high-speed data side is about $14,000 or $15,000 just for the radios, which is very expensive.
It's not because it's proprietary, it's because other
It's
manufacturers.
not. Yeah, it's not because it's proprietary. It's just the price has not come down. It's brand new technology. It's only really now starting to get more widespread utilization. I mean, there's only a couple of these in New York City at all, and I believe there's only one that's hooked to a gateway that can put it out on the internet. We'll talk about that in a second. Handheld radio is less than about $375, depending new, and then so this is one of those radios.
It's upside down.
You know, this camera thing really messes you up if you're dyslexic. So here's one of these radios, and I don't want to get too much in D-Star, but it gives you the capability going through the internet or a backbone that you create using Wi-Fi. They even have a 10 gigahertz handband link that you can link at 10 megabits between sites. And you can talk digital voice between two people without a repeater, between a repeater covering a large area, or repeater to repeater linking, or repeater to reflector, which is like multiple repeaters connected together covering a large area. Now, like I said, you can connect that to a gateway that can connect to the internet. You can just dial up a repeater in a faraway place. You're dialed up to your local repeater, you change the settings, and you're popping out in London on a frequency. You're in New York, you're popping out on a frequency in London just like that. It's very appliance operator oriented, not experimentation. Some other projects, some other things that are out there for digital communications is Project 25, P25. That was created by the Association of Public Safety Communication Officials. The intent here is to use this for police departments and public safety fire departments to communicate with each other. But this stuff is just starting to hit the surplus market a little bit, but it's still very, very expensive. A used handheld will run you over $500. But it does have the ability to have encryption in it and turned on. You're not allowed to do that in the handbands. But if you were to program it on MERS, then there's absolutely nothing that says you cannot use full-on P25 encryption on MERS. And I mean, that's built to the level that police are using it, so you're using basically the same technology as the police. Now, the fact that they're going to P25, which is a digital mode, you know, everybody, oh, we got to go digital, we got to go digital, everything's got to be digital. Interestingly enough, I believe the New York City Police Department is staying analog on UHF because it works better.
It's much easier to monitor too.
Yeah.
With like a police scanner, there are police scanner, there are like scanners like this one here, but they generally cost between $300 to $500 that will allow you to listen to unencrypted digital APCO 25 transmissions.
And I mean, you know, the TSA uses APCO 25 radios, Simplex, and they all bought and paid the money for them all to be encrypted. Nah, it takes too much effort to put the encryption keys in them. So they're all wide open. I mean, I've never listened to them. I've never bothered. They don't really, it's not that interesting. But they're using them. Your government dollars paid several $1,000s for each of these radios to have encryption, and I've yet to ever hear of anybody who's actually using the keyloaders. But what I was going to say is because a lot of these police departments are buying Project 25 radios, an interesting development is that these non-digital radios that work really well, like a Motorola Sabre, with encryption modules are coming onto the used market. And what used to be the problem was the keyloaders. You could not find the keyloaders. They were $800, $600. Now they're $150 because they're just flooding out on. Now you may have to make the cable and you may have to do a lot of stuff and a lot of reading. If you want to get into that stuff, go to batlabs.com. They're great. Okay, batlabs.com. They will tell you everything you need to know about Motorola radios. B-A-T, labs. Okay?
Don't be afraid about the high price of the new technologies that are coming into radio, because they all come down and they all hit the surplus market at some point. Most of us that began with 2-meter repeaters in the 60s and 70s, it all started with surplus Motorola taxi cab radios. As they came on the market, people they showed up at Hamfests for a couple of dollars. People changed them and made radios out of them. There's plenty of opportunities, and there's no reason to believe this isn't going to occur with some of these new technologies in a fairly rapid fashion. Why? Because the commercial entities, the Motorola's and companies like that, they want to keep selling the government agencies new gear. So the old stuff hits the surplus market and we get to benefit from it.
Really quickly, this is